For the period from 1980 to 2000, the percentage of households in the United States with at least one VCR has been modeled by the function V of t, or V of t is 85 over 1 plus 53 e to the negative 0.5 t. So we're measuring t in years since 1980. In what year was the percentage of households in the United States with at least one VCR at a maximum? Is this a good model for the percentage of households in the United States with at least one VCR after the year 2000? Well, we'll answer that after we do the maximum question. Okay, so let's look at finding a maximum value for V of t. So I'm looking on the interval 0 to 20, right? 1980 to 2000. So I'm just looking from 0 to 20, and I want to find a maximum value in there. So first, I have to look for critical points. So to find critical points, I take V prime and set it equal to 0. So my derivative here, I'm actually going to rewrite V of t first to help make taking the derivative a little bit easier. So I'm going to rewrite it where I move my denominator up to the numerator, and just throw an exponent of -1 on it. So then I can take V prime of t using the power rule and the chain rule. So I have some stuff raised to the -1, so I'm going to use the power rule on the stuff, bring that -1 down, and I get -85 times the stuff, just copy this stuff down, to the -2. And then I have to multiply by the derivative of the stuff, right? So the derivative of the stuff in parentheses here, the derivative of 1 is 0, that goes away. And then the derivative of 53 e to the negative 0.5 t would be 53 e to the negative 0.5 t times negative 0.5 for the chain rule. And then I have to set that whole thing equal to 0 and solve it. So let's try to simplify this a little bit before I start trying to solve. So I just want to make this a little bit simpler. I could divide out my 85. I could divide out this 53 and this negative 0.5 and the negative 85. So I'm just going to divide both sides by all of those. Okay, so these all go away. And 0 over anything is still 0. So I've drastically simplified this so that I now have e to the negative 0.5 t. That's this guy, right? And then I still have this guy here to the -2. I'm going to move that to the denominator and make it the +2. 1 plus 53 e to the negative 0.5 t squared. Okay, so that denominator can never be 0, and neither can that numerator, right? Fractions equal 0 when the numerator equals 0. So e to the negative 0.53, oops, no 3. E to the negative 0.5 t has to equal 0 for a fraction to equal 0, but this is never true. So it turns out that this function has no critical points. There is no place between 0 and 20 where this function has a horizontal tangent line. And in fact, if we analyze this derivative for its sign, exponential functions are always positive. And then here I have some stuff in the denominator all being squared, which will always be positive, right? So you have a positive divided by a positive, which will always be positive. So it turns out that this derivative, v prime, is always positive. And when v prime is always positive, that means that v is always increasing. So it must be that the maximum number of VCRs, right? The maximum number of VCRs would have to be at the end point on the right because the function's always increasing from left to right. So the maximum is at t equals 20, or the year 2000. Right. So the question, is this a good model for years after the year 2000? Is no, this is a terrible model because the number of VCRs in households is going to start to decline after the year 2000. So the model that we have is always increasing, so it would predict that the number of VCRs just continues to increase and increase and increase. So that's not a very good model.